We've got the algebra tiles out again, and I want to use them because I want to help you build up an intuition for what is meant by completing the square in algebra. So we're going to actually look at it in a geometric way first and then connect that to algebra. So if you remember, or if you've never seen this before, the blue square here represents x squared. Think of it as an x by x square. The green tiles here, the rectangles, represent x for each of them. So this is x times 1. The length is x and the width is 1. So all together here we've got an x squared, and we've got 1, 2, 3, 4, 5, 6 of the green tiles. Don't worry about the yellow squares for now. These are just worth 1 each. So if we're just taking the square and the green rectangles, we've got x squared plus 6x. Okay, so completing the square means we are going to try to take these shapes and arrange them to make a square that is complete, that is a complete square. I'll show you what I mean by that. If we have a square, that means the sides have to have equal length. So that's true for this square, but if I'm going to add the green rectangles to it, if I want the sides to have equal length, I have to split these half and half, right? So I have to split these 3 x's. I'll try to put them up here. And if I take these 3 x's and try to put them down here, I have the beginnings of what could be a square. Now, I'll remind you we're trying to complete the square. So can you visualize how this square could be completed? What do we need to add here to complete the square? Hopefully you've identified this area here as the part of the square that needs completing. And the way that we can do that is by adding in some of these yellow tiles. So this is 3 width here, and this is a width of 3 here, so that means we need 3 times 3. We need 9. Okay, so 9 of those tiles we have. And now you can see that we have a completed square. This length is x plus 3, x plus 1, 2, 3, and this side also is x plus 3, x plus 1, 2, 3. So what we've done here is to complete the square, we had to add these 9 tiles. So I'm going to write that over here. I had to add 9 tiles. And if you remember from factoring, the factored version of this is x plus 3 squared, which should make sense if we look at the square again. This is x and 1, 2, 3 on that side. And then on the height of the square, we have x, 1, 2, 3. All right, what if we had 8 x's? So I'm going to add a couple of these green rectangles here. What if we had x squared plus 8x? It's gonna have to make a bigger square, right? So let's see, if I add this piece here and this piece here, now what do I have to add in to complete the square? Well, I need a larger square down here, don't I? I need all of that to be filled in. And how many yellow squares is that going to take? Well, let's see, 1, 2, 3, 4 times 1, 2, 3, 4. And boom, look at that. We have another completed square. This one is larger. So to complete this square, we need to add 16 of the yellow small squares to it. So I'm going to write plus 16 there. And then again, the factored version of this, well, we have x plus 1, 2, 3, 4. So the area of that square is x plus 4 squared. Now, one more here. Let's imagine that we were going to do x squared plus 10x and repeat this same process without using the algebra tiles, or if you can visualize, think about what you might do here to complete the square. If you've noticed a pattern, the pattern that we're doing here is every time we have a certain number of x's, we have to square half of those x's. So in this case we had 6 x's, and then we had to split those in half, right? So we had 3 x's here and 3 x's here. And then the square that we had was 3 times 3, which is 9. So again, we take the number of x's, divide it in half, and then square it. 3 squared is 1/2. The same pattern works here as well. We had 8 x's. Half of 8 is equal to 4, and 4 squared is 16. So let's imagine the same pattern here. If we did 10 x's and we divided that in half, we would have 5. 10 divided by 2 is 5, and then 5 squared is 25. So using this pattern, you might predict we should do plus 25 here, and the result then would be x plus 5 squared. I'm just going to rearrange the algebra tiles and check to make sure that that works. Okay, so there we go. I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so that's 25 yellow squares that I had to add in order to complete the square. So you probably don't want to draw this picture or get out algebra tiles every time you want to solve a problem with this. So that's why we have a general rule, right? And it's the same as the pattern that I mentioned before. You take half of the number of x's and you square it. So in general, if we had x squared plus bx, we take half of this number and square it. So I'm going to write plus b over 2 squared. Okay, and then that works no matter what number you have for b. The trick here is the x squared must be 1. We'll talk later about what you do when you have an x squared that's not equal to 1.